Hi there. I thought I would tape a video today on the quiz that we took over the first part of Unit 5. So to get us started, we had cross sections. So it said the first one was if a cone is sliced parallel to the base. So a cone, of course, has a base of a circle. So a circle is the base of a cone. And if it's sliced parallel, no matter where it's sliced parallel to the base, it is always going to be a circle. Number 2, it says if a triangle is sliced perpendicular to the base, and the base here is a triangular prism, so it's a triangle, and if it's sliced perpendicular to the base, it's going to end up being a triangle, is going to be what it is. So that kind of shows the cross section that when it's sliced perpendicular to the base. Now notice, it doesn't matter how the triangular prism is placed, but it does matter that the base is always a triangle for a triangular prism. And then it says, which shape is possible for the cross section of a pyramid that's slanted to the base? So I'm going to kind of do this and show what it's going to look like. And it's going to end up being a four-sided figure, but it's not going to be a square because they're not going to be congruent, all congruent sides. It's not going to be a rectangle because the opposite sides are not going to be congruent. These two sides might be congruent, but those two aren't. This is going to be shorter than this down here. And then a parallelogram, not necessarily a parallelogram because it just depends. And then a trapezoid, definitely. It's going to be a trapezoid. So the next one is a cross section of a cylinder is always, sometimes, or never a rectangle. So if I was to cut this vertical to the base, it does create a rectangle. So it is sometimes, but it's not always, because when I cut it parallel to the base, then it is a circle, and then if I cut it that way, it'd be an oval, etc., etc. The next picture has two cones placed together, and if you slice a cone down the middle of the vertex, it creates a triangle. So basically it is two triangles put together, so your answer is B here. Number 6, this was displayed in class. So when I turn this, it creates a circle, the outer edge, and the inner edge is going to be shallower than the outer edge because it's going to make a big circle, and then it's going to have a dip in the middle, and then the bottom is also going to be a circle. So basically it is a cylinder with a cone cut out of the top, because this part right here is cut out. So the answer here is D, and this was one of the examples that we did in class. But also, you guys, look on the website, on this website, eClass, and you will see some sample, some websites that you can go to visually see this a little bit better. Number 7, it says, the graph of which equation is perpendicular to the graph of this line? So the first thing I have to do is I have to put this line into slope-intercept form because it says perpendicular, so I need the slope of this line to then find the slope of the line perpendicular. Plus 12, and then I divide by 3, divide by 3, divide by 3, so y is equal to -4/3 x plus 4. Okay, so this is the slope of the line that we currently have, but I want one perpendicular, so the perpendicular slope is going to be the opposite sign, so it's going to be positive, and it's going to be the reciprocal, so it's going to be 3/4. So right off the bat, I can eliminate everything but A, because this is 4/3, so that's not right. -3/4, that's not correct. -4/3, that's not correct. So the only correct answer is A. I do not even have to plug in to find out what B is. I'm not given a point, so I can't plug in to find out what B is. So just by the slope, I know that A is the correct equation. Number 8, I've already done, and so it says use slopes to determine which statement is true about AB and CD. Well, the first, it says slopes. So the first thing I'm going to do is find the slopes of AB and CD. And so the slope of AB is negative 2/5, and the slope of CD is negative 5/2. And if you recall, the slope is y2 minus y1 over x2 minus x1 when I'm given points. So looking at these, it says it's parallel. If they were parallel, they would be exactly the same, and they're not the same. They're just the reciprocal, so no. Lines are perpendicular. They're not perpendicular because they're both negatives, and I know that it is the negative reciprocal, meaning it's going to have the opposite sign if it is perpendicular, so it's not that. If it was coinciding, that would mean that it's going to have the same slope, and they don't have the same slopes. So I'm left with none of these. Number 9, it says an equation of a line parallel to this line. So right off the bat, if it's parallel, I know that my slope is going to be -3, so I can cross out C and D automatically. And then I'm going to use my point that is on the line to plug into the slope-intercept form of a line. I'm going to plug in y, so that's -2. I'm going to plug in m, so that's -3, and I'm going to plug in x, and that's 1. And I'm going to solve for where this line is going to hit the y-axis. So -2 is equal to -3 plus b, and then add 3 to both sides, so b is equal to 1. And so my correct answer is this. Now I had the choices of these lines will both be perpendicular, but this line will not go through the point 1, -2. So it's B is your answer. And then number 10, it says determine the equation of the line tangent to the circle at the point of tangent that is 7, -2. So the first thing I did was I plotted 7, -2. The second thing I did was I found out what the center of my circle was, because I need to find the slope of my radius. So I found the slope of my radius, and the slope of that is -4/3. And I just plugged it into the slope formula. From -4/3, or knowing that that is, I know that the line that is tangent to the circle is perpendicular to the radius. So I know that the perpendicular slope, or the slope of the tangent, is going to be 3/4 because it's the negative reciprocal. And then I have the point that it goes through. That line is 7, -2, so I use my slope-intercept form of the equation. I plug in y for -2, 7 for x, and 3/4 is going to be the slope of that line. And I multiply it out, and then I solve for b. So I am left with b is equal to -29/4. So A is going to be your equation of the line because it goes through this point, 7, -2. This would be perpendicular to the radius, but not go through the tangent line and not be tangent to the circle. What is the distance between C and D? So I use the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. So the distance is equal to -4 minus 6 squared plus 5 minus -3 squared. So the distance is equal to the square root of 10 squared, so -10 squared is 100, plus 8 squared, which is 64. So the distance is equal to the square root of 164. And whenever I put that into my handy-dandy calculator, I find that the square root of 164 is equal to 12.8. The next one asks to find the midpoint of this point, so I have to know the midpoint formula, and these are not the midpoint formula and the slope formula are not on your formula sheet, so you definitely need to make sure that you are memorizing that. So I add my x's together and divide by 2, and I add my y's together and divide by 2. So 6 plus -4 divided by 2, and then -3 plus 5 divided by divided by 2. So it's going to be 2 divided by 2 and 2 divided by 2, which simplifies to 1, 1. So the answer is D. Here it says find the length of the mid-segment, MN. Now I could have done this a couple of ways, but I did it. I knew that it's because it's the mid-segment, it's going to be parallel to my third side, and it's going to be half the length of my third side. So if I find the length of my third side, and I just use the formula, 8 minus 4 squared plus 5 minus 1 squared, it equals to the square root of 16 plus 16, square root of 32. So the length of that third side is the square root of 32, which ends up being 5.7, or actually 5.6. So that's 5.7 or 5.6. So that's the length of this. So it ends up being the square root of 32. So I have to take that length, because MN is half of that, I have to divide it by 2. And it's 2.8. Now, I could have actually used the midpoint formula, found my points, and found the length using the distance formula of those 2 points. You can do it either way. They both ways will come up to be 2.8. Number 14, it says determine the area of ABC, and I can just use the area if it's a triangle, okay? And I can use the formula base times height divided by 2, because I can easily count that the base is 8 and the height is 3, and so it's 24 divided by 2, which is 12. Okay? Now, I could have found the whole entire area of the rectangle and then subtracted out, but because I know the length of the height and the base, I didn't really need to do that, but you definitely can do it the other way. Number 15, it says determine the perimeter. So I have to find the length of AB, which ends up being the square root of 13, and I have to find the length of BC, which ends up being the square root of 45, and the length of AC, which is 8, I just counted, and add those together, and that's my perimeter. So the distance formula can be used to find the length of AB. You can also use the Pythagorean theorem to find the length of AB, because that's the hypotenuse with the legs being 3 and 2. You can do it either way, but I know that I have to find the lengths of all of the sides and then add them together, and the answer is 18.3. Number 16, this is a situation where we have a quadrilateral that I need to find the area of, so I need to find the area of the shaded region. I know that if I form a rectangle, like it says, it's 10 by 8 rectangle, so the area of that rectangle is 80, but then I need to find the area of each of the individual triangles so that I can subtract those off. So I find 4 times 5 is 20 divided by 2 is 10. 5 times 2 is 10 divided by 2 is 5. 4 times 6 is 24 divided by 2 is 12. And then 6 times 4 is 24 divided by 2 is 12. So I take 80 and I add up 10, 5, 12, and 12, which is 39, and subtract it off, and I'm left with the area of the quadrilateral is 41. Number 17 was the bonus. It was worth 5 points, and it says find the volume of the solid generated by rotating the figure around the given axis. So this is the axis right here. It's given. So when I rotate this, I'm going to create basically a cylinder that's on its side, and the radius of that cylinder is 4 and the height is 3. So I use the volume formula for a cylinder, which is on your formula sheet, which is pi r squared times h, and I just plug it in. So I have 4 squared times 3, and so V is equal to, I do believe it's 48 pi, which will simplify to 150.8. And that's your quiz. So hopefully this will help you.